Okay, welcome back. So yesterday we were doing inequalities of rational functions, and in our last step we actually got a factor of the polynomial that is in degree 3. In other words, that factor is a cubic polynomial. But unfortunately, we could not factor out easily and nicely in integer coefficients. So it actually left us a problem that how should we figure out the root of that part of the polynomial? And is there any way that we can actually get a general solution for any cubic polynomial? So today we're going to talk about such a problem. So we start with the general expression a times x cubed plus b x squared plus cx plus d equals 0, where a, b, c, and d are just numbers. So here we will assume that they're real numbers, but even if we expand it to the complex world, it will still be valid for the solution that we're going to find. But of course, we also need one more condition, that a is not equal to 0. And again, the reason that a cannot be equal to 0 is because we call a here is as our leading coefficient. And if we have our leading coefficient equal to 0, it doesn't make sense, first of all, because in other words, we can add all the higher terms. And also, if we assume that a is equal to 0, then we can just substitute in here. And now the first term, ax cubed, will be disappeared. And we'll end up with just a regular quadratic equation. So here we just need to assume that a is not equal to 0. And that's it. And of course, if d is equal to 0, we can just factor out easily, and then we will just reduce the polynomial into a factor of linear term and a factor of quadratic term. And of course, we know how to find solution for quadratic equation or any quadratic polynomial. So here we're going to talk about how we can find the general solution for a cubic polynomial like this. So first, I need to mention the method that we're going to use. We're going to find the Cardano formula. So Cardano is an Italian mathematician who actually first published a general solution for any cubic equation like this. But of course, he only found the real parts. And again, that's because at his era, the idea of complex numbers was not developed yet. So people at that time did not know the existence of complex numbers. So therefore, in that formula, we will only get one solution instead of all three solutions. So in this video, we will talk about that particular solution first and see how we can actually derive the general equation into the formula. Then for tomorrow, we will try to see if we can derive the other two solutions. Okay, so here we go. So first of all, the method that Cardano used is to depress or try to degenerate the equation of cubic polynomial into something that has no x squared term. So similar to how we derive the quadratic formula, of course, first thing first, we would like to divide everything by a, so that instead of having the leading coefficient be some random number, we can just fix it into 1. So this is what we're going to get. Now we divide everything by a, and again, a is not equal to 0, so that this division is valid. Then how do we get rid of the x squared term? So we can do a substitution. What we are going to do is we will let capital X be equal to x plus b over 3a. Again, why? Because if we try to cube both sides, we will now get x cubed, capital X cubed is equal to x plus b over 3a, quantity cube, like this. And then if we factor it out, we will now get x cubed plus this times x squared times 3, of course. Don't forget the 3. Plus 3 times 1 copy of this and 2 copies of that. So we will end up with something like this. And then plus b cubed over the cube of this. So we will get 27a cubed. So if we try to simplify it, we'll actually get something like this. Notice that in the x squared term, the 3's are going to cancel out. So we end up with the following. Good. So in other words, now we can just combine the first two terms in our equation into the term with respect to x, capital X, and of course we still have some lowercase x here. So we will end up with capital X cubed minus, so we're going to put the last two terms to the left hand side by subtracting them. So we'll get the following. Great, so this is how we substitute for the first two terms. So now we still have the third term, c over a times x, plus the last term, which is the constant term, d over a. Then now we need to combine the like terms. If we combine the like terms, we will get, here we have 3ac, so we multiply both top and bottom by 3a, minus b squared times lowercase x, plus 27a cubed on the denominator. So how much did we multiply? We multiply the bottom by 27a squared. So what do we need to do to the top? Same thing. A squared minus b cubed equals 0. And last but not least, we still have the lowercase x here. So we need to do substitution one more time. So from what we started off with, we assume that capital X is equal to lowercase x plus b over 3a. So if we move the constant term to the left hand side, we now get lowercase x is equal to capital X minus b over 3a. Good. So now we need to combine the like terms one more time, which gives us capital X cubed plus the quantity right here times x. So here, if we multiply it, we have 9a cubed in the denominator. So in order to match with the denominator of this fraction, we need to multiply the top part by 3 to, to get the same denominator. So we will end up with 27a squared d minus, let's see, we have minus here times 3acb. So we have minus 3abc. But we also need to multiply by 3 one more time. So we end up with 9abc. Then we also have negative b cubed times another negative, giving us positive. So we have positive b cubed, but don't forget we still need to multiply this by 3 to match the denominator. So we actually end up with 3b cubed minus another b cubed. So we end up with plus 2b cubed, like this. And as we can see, the coefficients are actually quite not so friendly. So I'm going to do a substitution, or just give a name for those coefficients. So we're going to call the first coefficient of the x term lowercase p, which is equal to 3ac minus b squared over 3a squared. So for the constant term, let's give it a name, maybe q. So we have q equals 27a squared d minus 9abc plus 2b cubed over 27a cubed. Good. Now, we're gonna move on to the next board and then continue our calculation. Okay, so from the last board, we end up with the step x cubed plus px plus q equals 0. Now here is the problem. What can we do? We cannot really reduce it one more time to get x cubed equals some constant anymore. So here, Cardano actually gave a brilliant method that we're going to do another substitution, which is we're going to let, I'm going to use this pen. We're going to let lowercase u and v be some other variables, and we have the sum of u and v equals capital X. So what does it do? Well, we're now going to get the following. If we substitute in, we have the cube of u plus v plus p times u plus v plus q equals 0. Then if we expand the first term, we get u cubed plus 3u squared v plus 3uv squared plus v squared, v cubed plus p times u plus v plus q equals 0. Good. And then what he did is he decided to group some of the terms together. So he grouped the u cube and the v cube together, as well as the q. So let me put a big parenthesis like this. Then for the remaining term, we have 3u squared v, 3uv squared, and then the p times the quantity u plus v. So for the first two terms, we can factor out 3uv so that we end up with u plus v. And we now can just factor the u plus v from these two terms. And here, so that the first term first two terms will now become 3uv and then plus p, which is equal to 0. Great. Now again, u plus v itself is just the variable x. So we just might as well assume that x might not be always equal to 0. So in this case, we will actually end up with the following. So in order to make this equation to be equal to 0 all the time, where u plus v could be random, we have to satisfy that this equation that by that each part in blue parentheses is always equal to 0. In other words, we actually end up with the system of equations. U cubed plus V cubed plus Q equals 0, and 3UV plus P equals 0. So we can just try to rewrite this and also do some substitution. So keep in mind, at this moment we have U plus V equals capital X. So we can might as well just put it right here. And then we're going to do a quick substitution again. So this time we're going to let capital U be U squared, U cubed, and capital V be V cubed. So what would the system of equations turn into? The first equation will now become capital U plus capital V equals, and I'm going to move the constant Q to the other side, which gives us negative Q. For the second equation, we can do the similar thing. First, we move the constant P to the other side to get negative P. Then, we're going to divide both sides by 3 to end up with negative P over 3. But notice that we have lowercase uv, and in the new system, we want to use new variables, capital U and capital V, which are the cube of lowercase u and lowercase v, respectively. So how can we get from lowercase uv to capital UV? We're going to cube both sides so that now we have capital U times capital V equals the cube of the right-hand side, which is negative P cubed over 27. Excellent. So let me clean the board, and then we are going to finish up the proof. Okay, so in the last board, we actually ended up with a system of equation with two variables, capital U and capital V. Now we actually have two equations which represents the sum and the product of the two variables. And if we look carefully, it's actually similar to one of my old videos that when we have two different variables and the system of equation where one of them is representing the sum and the other one is representing the product. So for the old viewers or my old audience, you perhaps already noticed how we should solve this. So we can just now let it as an equation with a variable, let's call z, so that z minus u times z minus v is equal to 0. In other words, capital U and capital V are the solutions for the equation with respect to the variable z. So if we expand the left-hand side, again, we will get z squared minus the sum u plus v times z plus the product uv. So what does that mean? It means that now we actually get the following. We have z squared plus qz minus p cubed over 27 is equal to 0. So if we solve for z, is the same is equivalent to solve for capital U and capital V at the same time. So now we just need to use the quadratic formula to help us. According to the quadratic formula, we have 2 times a, which is 1. And then on the numerator, we have negative b, which is negative q. Don't forget, q here is a constant. And then plus or minus the square root of b squared, which is q squared, minus 4ac, where A is 1, C is negative, so we end up with positive. We have positive 4p cubed over 27. Good. And notice that we have plus or minus. That means that U and V, one will take the positive sign, the other one will take the negative sign. So now we can just do substitute back so that we will be able to solve the equation. So since capital U and capital V are equal to one of them is equal to positive, the other one is equal to negative, and both of them are just cube of the original, well, I shouldn't say original, but the lowercase version. That means lowercase uv will be equal to the cube root of this term right here. Like this. And notice that we need to solve for x, right? So let's try to do the scratch word on the right quickly. Since we are trying to solve for x and we know what lowercase u and lowercase v are respectively, so from this line up here, we can just move the b over 3a to the other side to give us x equals negative b over 3a plus u plus v, which means here is our final solution. Our general solution for cubic formula would be x equals negative b over 3a plus u, and again, u and v are representing two different values, but since we're having addition, they're interchangeable, meaning that it doesn't matter which one goes first and which one goes after. In math, or advanced level of math, we actually call this associative. So, excuse me, not associative, commutative. So anyway, it means that we just need to now substitute back in to get our solution. So we will take one of them. Let's say we take a plus sign first. So we will get u equals this plus v, and this time we need to take the other sign. So this time we need to take the negative sign since we chose the plus sign for the first one. And here is our general solution, or the partial cubic formula for a general cubic equation. So I'll pause the video right here, and for the other two solutions, we're going to talk about it more hopefully by tomorrow, or I'll make sure that I'll make a video to talk about it within 2 weeks. Thank you for watching. I'll see you guys next time.